Heavy metals influence the composition of gut microbiota. They will modify pH and they will cause an alteration of the environment that will inevitably lead to a change in the intestinal ecosystem. Once we have an alteration of the microbiota, we will encounter problems with the gut-brain axis, which will introduce more factors, combining more factors that can ultimately lead to neurological damage. And this is the most complicated scenario within microbiota alterations, which would be endotoxin, when there is an increase of a type of microbiota that carries lipopolysaccharides, a substance called endotoxin. This area of certain gram-negative bacteria, and if we add to that an increase in permeability, we already have a scenario of chronic low-grade inflammation. On the other hand, the great importance of the gut, of course, for me, is that it is the largest detoxification organ when we talk about the gut with its microbiota. And there is also a point of connection between heavy metals and this, which is dysbiosis induced by heavy metals. Heavy metals create a type of dysbiosis that, from what I have seen, is among the worst. They generate significant losses of functional groups and impressive overgrowths. We have to consider that the microorganisms in the gut will grow, certain groups or others depending on the food that is present there. Many times there are parasites in the intestine because of heavy metals. Recurrent candidiasis is related to mercury. Many times a person can be endlessly treating their intestine, but if they have amalgams that are emitting metals, it is difficult to resolve. It is a type of dysbiosis that also leads to increased intestinal permeability. So 2021, the mess is already served as we have a leaky gut through which, among other things, metals present in the intestine will pass. The metals that arrive orally will go directly into the bloodstream. So I think these are very important things. And this slide summarizes one of the classes we give in the course, which is the description of dysbiosis induced by heavy metals, a topic that I find fascinating, and how heavy metals and microbiota influence each other bidirectionally. And when the presence of heavy metals has already caused significant damage to the microbiota, we become much more defenseless to this exposure. And on top of that, we produce endogenous toxins, making the situation unsustainable. This in turn overloads the liver, which also begins to have difficulties coping with such a toxic burden, not only from xenobiotics, but also from endobiotics. So, heavy metals influence the composition of the gut microbiota. They will modify pH, and they will cause an alteration of the environment that will inevitably lead to a change in the intestinal ecosystem. And a healthy gut microbiota reduces the absorption of heavy metals in the intestine and converts them into more or less toxic forms. The modification caused by heavy metals in the microbiota increases the risk of metabolic diseases, allergies, and asthma. This is taken from a study that related it to metabolism, but we can also relate it to autoimmunity and neurodegeneration for sure. On the other hand, the good news is that intervention with probiotics or diet, or anything that helps restore the intestinal ecosystem, will promote the excretion of heavy metals via feces, will enhance the detoxification enzymes for heavy metals, will modify the structure and function of the microbiota, will promote the synthesis of short-chain fatty acids that are essential, and will protect the intestinal barrier. Therefore, if we are very exposed, it is interesting to intervene on the gut, protecting with probiotics for the homeostasis of the protective microbiota. Once we have an alteration of the microbiota, we will encounter problems with the gut-brain axis, which will introduce more factors, bringing together more factors that can lead to neurological damage. We have alterations with the loss of neuroactive microbiota, which will result in a lower production of GABA and other neurotransmitters. In other words, this is directly related to neuronal damage and can be induced by the presence of heavy metals, among other things. And of course, well, neurotransmitters, as you know, about 80% of serotonin, if I remember correctly, is used by the brain, is produced in the intestinal neurons, produced in the gut, and I believe it is 50% of dopamine. So we can have a very healthy brain, but it may not function well because it doesn't receive the substances it needs to make a good synapse. 1. Good neurological transmission. Of course, what I was saying is that an alteration of intestinal permeability leaves us much more exposed to heavy metals. This has its good side, which is that a healthy gut allows us to have a great capacity to degrade xenobiotics and to cope with the world we live in. So it is not a matter of shutting ourselves in, isolating ourselves, and generating a paranoia about this, but rather of taking care of certain elements that are our great, great allies. And let's not forget that all these microorganisms that coexist with us in our gut are also affected by what affects us. So taking care of ourselves means taking care of them. And this is the most complicated scenario within microbiota alterations, which would be endotoxemia when there is an increase of a type of microbiota that carries lipopolysaccharides, a substance called endotoxin, this area of certain gram-negative bacteria. And if we add to that an increase in permeability, we already have a scenario of chronic low-grade inflammation. We can resolve the permeability, and we will have local inflammation in the gut. If we resolve the permeability, but if there is a simultaneous increase in permeability or an increase in LPS, we will encounter chronic low-grade inflammation. In other words, we already have by itself chronic low-grade inflammation, along with that leak of toxins. And then we have, I believe that the presence of heavy metals induces the formation of pathogenic biofilms. Pathogens grow significantly, forming these superstructures that cease to behave like a unicellular organism and start to behave like something multicellular, where those microorganisms living in those biofilms change their phenotypic expression and begin to produce much more toxins, complicating the situation. So this is a bit the point where we link heavy metals and the formation of biofilms with microbiota alterations, dysbiosis, and then, as an interesting fact, amyloidosis, which you know is associated with various chronic pathologies, including Alzheimer's. Well, there are different studies that lead us to different points, and it is interesting to see things that make us break away from what we have read or established. It is very interesting to question. It is very interesting that we read all things, but we have to process, internalize, and see if they fit or keep searching. So the beta amyloid protein, besides what we have always talked about, being the part that causes the problem, may not be the part that causes the problem, but rather a consequence of the biofilms. Bacteria synthesize these amyloids. So those formations, superstructures like biofilms, may be related to the formation of beta amyloid protein, but this that we consider bad turns out in another study I read that I found very interesting to suggest that this protein is a detoxification mechanism and a defense mechanism against infections. So, well, there it is, right? Whether it is a cause, a consequence, whether it should be the target of treatments or not at all, because it may be a repair mechanism. Just as I was saying about the intestines, deworming when there is a parasitosis, huge bacterial overgrowths that have been induced by the presence of toxins in the intestines. If we only do that, it is not interesting because it is a resource of nature to remove the presence of toxins that would be much more harmful. So we need to clean the environment simultaneously of toxins and pathogens. A reminder, we have between 15,000 to 33,000 million neurons, depending on age and sex. Each neuron can be interconnected with 10,000 synaptic connections. In fact, it is not more neurons, but the intellectual speed is given by the connections. In fact, the brains of geniuses did not have greater mass at all. Each cubic millimeter of the cortex has 1,000 million synapses. The truth is that it is a surprising thing. The maximum maturation of neurons is reached between 21 and 25 years, and from there we have to maintain them with the best functionality possible. And within that, it would be to avoid neurotoxins. And neurogenesis is known to be maintained at certain points over the years. It was previously thought that there was no possibility of generating neurons, but today we know that there is. It is not everywhere, but for example, in the olfactory bulb, if I remember correctly, there is a very interesting point of neurogenesis. I believe this is one of the abilities that is lost when there is a disruption of communication between neurons, when there are communication problems between the two brains. I believe one of the things that is hindered or lost is the ability to renew neurons, the ability to generate neurogenesis. And neurons need to breathe, they need nourishment, they need rest, and they need not to be intoxicated. So we will be very attentive to all those homotoxins that are neurotoxic. And we talk about homotoxins as any substance, any toxin that can affect the organism. One very interesting concept is that it does not necessarily have to be exogenous. It may be that it was not toxic per se, but that a transformation occurs within the body that turns it into neurotoxic or toxic in general. But here we are talking about neurotoxic. Exogenous homotoxins are all these environmental elements, including heavy metals, the heterogenic ones, and the voluntary ones, which would be drugs.